Hi, Pre-Calc. This week we are going to review arithmetic and geometric sequences and series, and then move on to simplifying complex fractions. So I have an exciting week planned for you. So far, what we've learned about arithmetic and geometric sequences and series are the following formulas. Hopefully you have these written down in the notes that you took off of the Yay Math videos. If not, when the video is over, maybe you want to rewind and then copy those things down. You're going to need these formulas for quick reference when you're doing the homework today and tomorrow. Not only did we learn about sequences and series, but we also were introduced to sigma notation. Sigma is the Greek symbol for sum, so that's also sometimes called summation notation, and it's really easy to interpret. Underneath sigma, the bottom number is your lower index, and then the top number is your upper index. And then to the right of sigma is whatever formula it is that you're going to be using to find a sequence and then sum up all of those terms. So if I had 2n for my formula, I'd go 2 times 1, and then 2 times 2, and then 2 times 3. So 1 to 3 because I'm going from 1 to 3. So 2 plus 4 plus 6 gave me 10 plus 2 or 12. All right, then on Friday, I had you watch that video. My kids told me that that was some YouTuber I should know. I don't know. I hope he's a okay guy, whatever. I just thought it was funny. We've got this pyramid of red solo cups, and then he drops down on it and they go flying everywhere. I thought, hey, that's a geometric or arithmetic or some kind of sequence or series, probably. And also, we can do a little bit of unit conversion to figure out how much that expensive or how expensive that experiment really was. Okay, so what I noticed about the pyramid of solo cups was that the base was probably a 20 by 20. It looked to be 20 wide and 20 long. And then we know that that's going to be a solid, like, square of solo cups. Otherwise, we couldn't build the pyramid. And then I very carefully paused the video and counted, and it looked like he had completed rows 20 up to row 4. So on the base, you had 20 by 20, and then on top of that would have been the 19 by 19 level, and the 18 by 18 level or layer, so on and so forth. And I thought, oh, I can figure out how many cups he's already used using summation notation or sigma. So if I add from 4 to 20, all of those perfect squares, my calculator told me 2856. And if you don't have a calculator that's got that math zero menu or feature, then you can just Google a summation calculator and it will pop up and, right in the Google box. So anyway, I figured out what the sum of the first 20, or well, squares from 4 to 20 anyway. That was 2856. And then it looked like he was working on placing a fourth cup on that next, like, 3 by 3 row. So, by my estimation, he's got about 2,860 solo cups there. So, then if I know that I can buy 50 cups for 388 at Walmart, how many packages of 50 do I need? Well, 2,860 divided by 4 came out to be 57.2. I can't buy zero point 0.2 of a package of solo cups, so I rounded up to 58. 58 times $3.88. That was a $225.04 experiment, or waste of plastic, if you ask me. All right, so in your homework today, you're going to find a couple, or quite a few problems, but a couple that you might not have seen before or might not really know how to approach at this point in time. For example, you might be given some sort of a sequence with some missing terms and then be asked to find the missing terms. They'll tell you whether the sequence is arithmetic or geometric. So let's take a look at this portion of an arithmetic sequence where we've got 3 and then something and something, and then the next term would be 18. So even though the sequence obviously goes, to the left and to the right on the number line of 3 and 18, I'm just going to say, you know what, we're going to call the first term 3, and then the fourth term relative or in reference to this first term will be the fourth term. An arithmetic sequence looks like this. A sub n is equal to a sub 1 plus n minus 1 times that common difference. A sub 1 is 3. A sub 4 is 18, so I'll plug 18 there, and 4 for n. N is whatever term you're talking about in the sequence. Whoops. Okay, so anyhow, then we do some math. 18 minus 3 is 15. 4 minus 1 is 3 times d. D is equal to 5. Our common difference is 5. So to move through the sequence, 3 plus 5 gives me 8. 8 plus 5 gives me 13. 13 plus 5 gives me 18. So my missing terms are 8 and 13. All right, let's take a look at this next example. So this is where things get exciting. We're going to evaluate the geometric series described as having a first term of 2, an nth term of 93,312, and a common ratio of -6. So over here in red, I wrote down what I know so far. Here's my formula for a geometric series. I know my first term is 2. I know my common ratio is -6. But what I don't know is what term is this 93,312? So what is n? I know that a sequence, so going back to things that I already know from my formula sheet, a geometric sequence is found by taking a first term times a common ratio to the n minus 1 power. So a sub n is 93,312, a sub 1, r, but I don't know what n minus 1 is. All right, well, clean out that 2. Easy enough. Now, wait a minute, hold your horses. How am I going to undo an exponent, or how am I going to get like an exponent, on my level? What undoes an exponent is a logarithm. So log both sides, and then your power kind of drops down in front, and then the log of -6 is a number. Wait a minute. Remember, you can't take the log of a negative number. Remember, those logs have walls, and that wall is at 0 unless you have some sort of a shift. Okay, so in the context of this problem, what we're going to need to do is just take the log of regular 6, or the absolute value of -6. So I'm going to take the log of 46,656 divided by the log of 6, and then that gives me 6, and add 1, and I come up with 7. Wait a minute, I better check that out. First term, common ratio to the 7 minus 1. 93,317. So my seventh term in the sequence would be 93,312. It checks out. All right, well, okay. So now what we're going to do is we're going to find the series. So let me back up a minute. Do you hear the doubt in my voice? Do you hear the uncertainty? Yeah, I'm not quite sure. This is fishy. The log of the absolute value of -6. I'm just going with it right now. I'm trusting myself to try something. I've got my formulas in front of me. Work with me. Work with yourself. Trust yourself. Okay, anyway, I want to find the series, the sum of the first number of terms. How many terms do I have? 7. And then 2 is my initial term, a sub 1 right there. 1 minus -6 is the common ratio. 7 is the number of terms that I'm summing together, all over 1 minus -6. Okay, I plugged it in my calculator exactly as it was written. Well, I lied. I put another set of parentheses around the numerator, and I put another set of parentheses around the denominator. Just use parentheses. Be careful. It gave me 79,982. Okay. Well, I mean, my math seems right. So you know what I did next? This was a series, or a sequence anyway, that it was easy enough to find the next few terms, and I was only looking at the first 7. So I went through and I kind of worked it out. 2 times -6, -12 times -6, 72 times -6, times -6, times -6, times -6. And then, yeah, I mean, 93,000 minus 15,000, we're in the ballpark of like, what would that be? 80 something, or 70, 75-ish, 76, 77. I don't know, take away 400, that's not going to really affect it. Add 72, nah. Subtract 12, we're talking pennies now. So anyway, run it through your calculator or do some good old fashioned adding and subtracting, and yeah, it works out to be 79,982. Okay, so you just need more practice to kind of build up your confidence and just to kind of work your algebra magic. So, in your Google Drive now, you'll find a PDF with some assignment, with an assignment on it with some problems. I think there's 9. Use your formulas, watch this video again, go nice and slow, and then when you're done, please upload your answers onto the attached to Google Doc. All right, thanks, guys. Bye.